Okay, I'd like to welcome everybody here to tonight's public lecture and our conversation. And it's entitled The Influence of Climate Change on Hurricanes. My name is Steve Goldstein. If you don't know me, I'm the interim director of the observatory, and I'm also a professor in the Department of Earth and Environmental Sciences at Columbia. Our public lecture series proudly features distinguished researchers from Lamont who are dedicated to uncovering the transformations our planet is undergoing and exploring the implications of both our broader society and our local communities. Okay? We believe that the scientific insights generated by Lamont are crucial for developing impactful solutions. And this year we're celebrating our 75th anniversary. And over this time, the scientific insights generated by Lamont really have been crucial to guiding impactful solutions throughout our history. Tonight we're going to hear from Professor Suzana Camargo, who's sitting on the side there. Suzana is an expert on the relationship between extreme weather events and climate, and in particular, hurricanes and typhoons. Suzana has been at Columbia since 1999, a little bit less than I have, actually. I came in 96. And she's currently the Marie Tharp Lamont Research Professor here at the observatory, and she's adjunct professor in the Department of Earth and Environmental Sciences. She's highly recognized, and she's received many scientific awards. Among them, she's a fellow of the American Geophysical Union, which is the top geoscience scientific society in the US. And beginning on January 1st, Suzana is going to be transitioning, and she's going to become professor of climate in the Columbia Climate School. And she's going to remain a Lamonter on top of that. So, given the recent significant effects of hurricanes, particularly the tremendous destruction by Hurricane Milton just a few weeks ago, which was far away from any coast, and just 2 weeks after Hurricane Helene, we're all conscious of their power and their potential for destruction. And so I'm confident that tonight's lecture will be both engaging and timely, and there will be opportunities to ask questions afterward. And so please hold your comments to the end of the lecture. And now I'll cede the floor to Suzana.
Thank you, Steve. Okay, welcome everyone. Special welcome to the NIAC crew. I'm going to talk about the influence of climate change on hurricanes. As you can imagine, I had quite an interesting hurricane season. From when the hurricane seasonal forecasts start to be released, they were all forecasting a record high activity. And we were waiting for this hurricane season. And what happened is that actually the hurricane season started very quiet. And this is the kind of email you're receiving from journalists in August, where basically if all the forecasts were wrong because it was too quiet. And then you guys know what happened afterwards. So we had Hurricane Helene, which had a record amount of rainfall in North Carolina. The forecast from the National Hurricane Center was perfectly spot. They were saying historic, catastrophic, and life-threatening flash and urban flooding and landslides, so they knew what they were talking about. Followed by the Hurricane Milton, which was one of the most intense hurricanes in the Atlantic region and had a record rapid intensification. And accompanied by a lot of tornadoes. These are the tracks of the tornadoes in Florida just before Hurricane Milton made landfall. So at this point, the hurricane season, by lots of different measures that we use, they're all very high above what we usually have in an active season. So the question is, did climate change influence the 2024 hurricane season? Can we say anything about that? And what can we actually say? And part of the difficulty for us to say this is that hurricanes are part of the climate system, right? We start by Columbus being affected by a hurricane in his fourth voyage. Actually, he had to hide in a harbor in the southern Hispaniola and managed to save his fleet, while there was the governor of Hispaniola actually had 29 ships sinking, and more than 500 people died. So we are talking about a long time ago. Then we have, for instance, the Great Hurricane of 1780, which killed more than 20,000 people in the Caribbean. So having these events is not something new. They are part of the climate systems, and that's happening regularly. We have in 1900 the Galveston hurricane, which was the deadliest US hurricane in history, and actually we don't know how many people died there. And then in 2008, we had another hurricane basically at the same spot and having very impactful, lot of impacts in Galveston as well. So how can I tell, looking at this, what is actually climate change when was actually what's part of the climate system, normal hurricane activity? So that's the difficulty, and that's what I'm trying to explain to you. First of all, how would climate change affect hurricanes, right? How would you know? So we know what climate change is doing. It's warming the planet. How would that then translate in affecting hurricanes? So in order to know that a little bit, I think I have to explain a little bit to you guys what we know about how hurricanes form and how they intensify. That will then tell us how climate change can affect them. So this is like my, you're making a hurricane, like you're baking a cake, is what you need. So you need a warm ocean, right? Hurricanes, they form over the ocean. So these colors here show you how warm the ocean is. Here is in typically August colors, so this is what we call the sea surface temperature. And you see that we have highest temperatures here, what we call the warm pool in the Pacific and near the Caribbean and the Atlantic. And these are regions that we end up having a lot of the hurricanes and the typhoons. So that's one ingredient, warm ocean. Tend to be August, September in the northern hemisphere, because it takes a while in the summer for the ocean to warm up. Yeah? If you go on the beach in June, the water is still cold, right? If you go in August, it's much more comfortable. That's it. So what else we need? A hurricane is a storm. So to have a storm, to have clouds, to have rainfall, we need what? Humid air. So we need humidity. Another important thing, see, we have hurricanes here. See that they all look, they're spinning, they're turning. So we need some spin, we need some turning. And where we have that, we don't have that in the equator. That's part of what you guys studied physics, the Coriolis effect. Tends to be is 0 in the equator and it's maximum in the poles. So when you're exactly in the equator, you can't make hurricanes either. And something else is what we call wind shear. Is basically, so you imagine the hurricane is like a tower of clouds, and it's my pen here. And if you have winds going one direction at the top, another direction at the bottom, you can sustain that. So that's the wind shear, this difference on either the magnitude or the direction of the wind. So if that is there, even if you have warm air, if you have humidity, it's hard to form a hurricane. So this is like what we call necessary conditions. And then we have these, what we call these disturbances. These are the case of the easterly waves. These are waves that come from Africa, and each of these maxima here is one of the these maxima of the what we call these tropical easterly waves. And this particular case, all of them end up being hurricanes afterwards. So you have these disturbances that come, and then if they have the right conditions, then they end up becoming storms that can become a hurricane. So then they start intensifying, but also they need some time, right? You need 5 to 7 days for the hurricane to become strong and become a category 1, 2, or 3, or 4 hurricane. If the storm formed very near land, for instance, doesn't have time to become a hurricane. So you can have things like if you have a cold ocean here, cold colors, and your hurricanes coming there, then it can affect the intensification of the hurricanes. Or if it's dry air, or all these things. That's why not all hurricanes become a Cat 5 hurricane, because you have these things that make them not intensify. So when we have all these things, then we can have hurricanes, and this is a plot of the tracks of here all the Atlantic hurricanes in this period, and then the Eastern Pacific and Western Pacific. And actually they are called hurricanes just in the Atlantic and in the Eastern Pacific. In the Western Pacific, they are called typhoons. And the reasons for that is basically historical. So the hurricane, the word hurricane comes from Mayan word. That's a god of the storms, hurricane, and that's how that word came. While typhoon comes from a Chinese word. So they are exactly the same phenomena. While we are here and worry about the Atlantic hurricanes, actually 33% of the tropical cyclones, which is the general word for hurricanes, are in the Western North Pacific. And then also by the colors here, see how intense they are. And you also, the most intense storms are also in the Western North Pacific. We just have about 12% of those storms globally, although all the media is focused here. And also we have in the Southern Hemisphere. See, this is lack of storms here. This is the equator region, the equatorial region is why I said we don't have storms there. So now the other interesting thing that when they form, so these are the months, and you see here in the Northern Hemisphere, they tend to form August, September, October. In the Southern Hemisphere, January, February, March. It's always late summer, early fall that you have the peak of the hurricane seasons. We have about 85 tropical cyclones per year. Only about half of them reach hurricane category. Okay, and then what do? We know about wind damage, and also we have storm surge, flooding, both coast and inland, landslide, lightning, and tornadoes. So the Galveston case that I mentioned first, that was a storm surge impact. So the storm surge is basically the winds of the hurricane really push up a lot of the water from the ocean into the coast. So imagine have a big fan in your bathtub, and it is a very strong fan, then the water is going to pile up in the other side, right? So that's basically what the winds of the hurricanes are doing. You have a big hurricane. The size of the hurricane is important. The intensity is important. What's going to determine the storm surge. Also, we can have a lot of rainfall inland. So here is the case of Hurricane Irene. that brought a lot of flooding in Vermont, which is similar to what we had, this case in Helene, this time in North Carolina. So these are not unusual events that we can have inland flooding. And we can have a lot of landslide. Again, Hurricane Helene had a lot of landslide. That's what a lot of the roads in North Carolina were destroyed. And similar here, Hurricane Maria, each of these colors here is having landslide in Puerto Rico. I had a lot of reporters asking about the tornadoes associated with Hurricane Milton, if that was something new. No, it's not. A lot of hurricanes, they lead to tornado formation when they are reaching land. Tornadoes, different from hurricanes, they form over land. So, and then the characteristics of this rain and the wind from the hurricanes getting into land can lead to tornadoes. And some of them had lead to lots of tornadoes. For instance, Hurricane Ivan in 2004 had over 117 tornadoes. So these are what the basics of hurricanes. So we want to understand now, what can climate change do to that? So let's think, for instance, the case of Hurricane Katrina. Yeah? We all know about Hurricane Katrina, 2005. We had massive storm surge because we had this very strong and large hurricane. We had lots of rainfall and led to the disaster that happened. But what is important whenever we have these disasters is not only the hurricane itself, the hazard. We end up having the disaster we had in New Orleans because we built a city below sea level with a pumping system and subsidence in the area. We had a levee system that failed. So while I can talk about what climate change is doing to this part, what we are doing in terms of development and building cities is very important as well. And it's a different aspect of this problem. So I'm going to be talking about what can climate change do in terms of the rainfall and the intensity, but we cannot forget that we wouldn't have the disasters if we're not contributing to that ourselves. Okay, so anthropogenic climate change. So basically, this is a graphic that's done by a British scientist, Ed Hawkins, the climate stripes. And each of these stripes is the global temperature that he's subtract the mean from the beginning of the 19th century. And then you can see each color here is the color of the global mean temperature from each year. So you can see here from 1850 to 2022, and globally, it's very clear that the planet is warming because we are putting greenhouse gases in the atmosphere, and that's what happens. So this is a very clear signal of anthropogenic climate change, the warming temperatures. And another one is sea level rise. So why do we have sea level rise? So a minor part is that because we have a warmer ocean and it's expanding, the water becomes ocean, but we also have, most importantly, melting of land ice, glaciers, ice sheets, ice cap. They are all going into the ocean. So then we have an increase in sea level rise. And as we are going to discuss a little bit, that's going to have also impact in the hurricanes. The sea level rise is important for that. So I try to tell you how hurricanes work. So how now can climate change influence hurricanes? So in a warmer climate, we are warming the ocean as well. So, and as I said, that's kind of this fuel. You need a warm ocean to have hurricanes. So now we are having a warmer ocean. We are also warming the temperature in the atmosphere, not only in the ocean. So that can be a that's when things start to be more complicated. It's not just like a linear relation about to have a warmer ocean, I have, what's going to happen with climate change. Then the physics start to be more complicated. Another very important thing, remember I mentioned that we need to have humidity to have hurricanes. And a warmer atmosphere can hold more moisture. And so we have more moisture available for the formation of hurricanes and for the rainfall associated with hurricanes. So it's not very simple how the things are going to work. So that's why we need more complex models to try to understand that. Also, we have sea level rise. When I talk about storm surge, it's like we are bringing this water from the ocean into land. So if you start from a higher level, then you're flooding, just even if the hurricane is not changing at all, just because you have sea level rise, you are going to have more flooding. So which characteristics could change? So we could have more hurricanes, fewer hurricanes, more intense hurricanes. Maybe they can last longer or they can be shorter. They have more rainfall. So these are all the things that can, or they can start having hurricanes locations we have. So that's what we try to understand. That's kind of the studies that I do. But we basically divide our questions in two parts. One is what's happening now, right? So can I say that there are already trends in the intensity of hurricanes, or the number of them, or how long they last? So for that, I need data of the past, and then I see if this data is changing, if there are trends. So the other part is, so this is what we call trends in the characteristics of hurricanes. The other part is like, can I say if a specific hurricane, like for instance, Hurricane Helene, was affected by climate change? So that part we call detection and attribution. So we have to detect if there is a climate change signal in the data, and we can say if we can attribute that to climate change or not. So that's the present climate. And then we have the future climate. So we know what's going on now. What's going to happen in the future, in 20 years, in 50 years, in 100 years? So that's what we call climate projections, which will depend on what's going to happen in the future. So it depends on the emissions. So how much more greenhouse gases we are going to put in the atmosphere. If these high emission scenarios, the range of what can happen will be different than we have, we start taking off. So these are the questions that I try to study. And we try to study that not only for hurricanes, for all kinds of extreme events. So this is a plot that the National Academy of Science put together a few years ago. And here is basically try to how well we understand different extreme events and how can we well can we model them. And for instance, extreme heat and extreme cold, they are in top here. These are the ones that we understand very well, how they respond to climate change, what's going on. We can model them well. Tropical cyclones are here. So we have some understanding and we can say some things, but there are a lot of things that we still have to understand. And one of the issues is this one, quality and length of the observational record, which here, see, this is low. So what's the problem here? The problem is, how would I know if there was a hurricane in 1902? Only if someone was there, right? And was affected by that hurricane. Or you're sailing across the Atlantic from Europe to US and your ship was affected, right? Or if you're living in the coast and you're affected. There were no satellites. We didn't know there was a hurricane. So if the hurricane didn't affect anybody, how on earth would we know there was a hurricane there? So when we look at trends, We want these very long data sets with data from as many years as possible. And that's the problem. A lot of our data for hurricanes, we do not have a very long, reliable data set because they're missing. In particular, the ones over the ocean, like, for instance, in the southern hemisphere, our data is much, our data sets are much poorer there. So that's part why, when in terms of trends, we look at terms of trends in hurricanes, it's very hard sometimes to say if the change is already occurring or not. So this plot here, these colors, each of these colors is one of those basins that I showed that has hurricanes. So we have in green here the Western Pacific, in orange the Eastern Pacific, and the blue is the Atlantic. So you have this increase here. Oh, climate change. Yeah? It's increasing the number of hurricanes globally. Is it true? No. Yeah? So here is marking when we start to have satellite. So all this increase here is because now we have better observations. We can know, we have more people being affected by tropical cyclones and things like that. So that's what's part to make very hard, this understanding these trends, because we have to separate the technological issues, and now we start having satellites, so now we are starting not to miss hurricanes, and from what's happening with climate change. So how can I separate that? And also, your satellite from 1969, I bet you is not the same if your satellite from 2020, right? So you think of resolution of your pictures in your phone, your older iPhones, they were much worse than they are now, right? Same thing with satellites. Our satellites were worse. So our satellite pictures were fuzzier and stuff like that. So now we are counting better hurricanes and things like that. Or finding these 2-day hurricanes that before we wouldn't even probably miss because we wouldn't even know that they happen. So that's the problem. Globally, they're not consistent at all before 1970, before the satellite era. And there are a lot of technology changes, how we monitor the hurricanes in this period. So really, we have reliable data to look at trends starting 1990s. It's only 30 plus years. So what can we say with the data starting 1990? We can say that actually there is a decrease in the number of tropical cyclones globally. And that's basically coming from the Western North Pacific. And then he has a measure that we like to use that combines intensity and number and duration, and that also is decreasing since 1990, like 30 years. But on the other hand, we are having more of this category 4 and 5 hurricanes, this very intense one. So the number, what we've seen the last 30 years, is that the total number is decreasing, but we're having more of these 4 and 5. Can we do anything about going back in time and trying to figure out if there were more hurricanes? Yes. So archival studies here from the record of the 1938 hurricane, people coming and looking at newspapers and going, there are people that, and that's their research, they go and rediscover these old hurricanes. Or something more similar to what we do at Lamont here, we look at geological proxies. So you can imagine there is a hurricane, it's coming, there's bringing a lot of storm surge, and that all this sand can go over, for instance, a barrier, and then in the back you have a lagoon, and if I go make a hole there, a sediment, I'll have a sediment, we have a lot of sand, I can identify that it was a hurricane there. And people do that with different geological proxies. They can do that in caves. Stalagmites also, they record the type of water that comes from hurricanes, so you can reconstruct that. You can do it in corals, for instance, the Great Barrier Reef, and blue holes in the Caribbean. We also can register the passage of hurricanes. So that's a whole side of research we call paleo-hurricanes, trying to rediscover all the hurricanes in the past, and we can estimate how much hurricanes we had in the past to help us understand these trends. So this is one part. So first, the trends. I try to give what we know so far. The other thing is, every time there's a hurricane, I get a reporter calling me, was this hurricane caused by climate change? And the first thing I have to say is no, because, hurricanes are part of the climate system. They occur all the time. So that's not the right question. The question is, can we say how much of these hurricane characteristics were modified by climate change? So let's think about, for instance, the case of Hurricane Harvey. If you guys remember, it was in 2017, and it stayed a long time over Houston and flooded the whole Houston area, so basically stalled there, and had the whole region was completely flooded. Similar to Katrina, it was a big disaster. We had this hurricane just stay in a place for a long time, so the amount of rainfall was record. But we built a huge city in a very flat area with tons of housing developments in flooding-prone areas and a lot of urbanization. So where would all the water go? Yeah, this is a floodplain. And now you have everything going where? You have cement, you have asphalt, so that contributes, all that contribute to the flooding. So every time you have a disaster, you have the contribution, what we're doing to the hurricane itself, but then we have all this part that's other things that we as humans are contributing, they're not climate change. So there are a lot of studies that look at Hurricane Harvey and try to estimate how much of that rainfall was due to climate change. And the different studies doing different methodologies, using data, using models, they come to this range. Basically, 6 to 20% of the rainfall was an increase in the rainfall in the case of Harvey due to climate change. So could we have had something like Harvey before? Yes, we could. But what we're basically, if you're in a casino, you're playing dice, and then now we're basically loading your dice so that you're having a higher probability of one thing than the other. That's what we're doing by climate change. And also there was a very interesting study that not only climate change exacerbated this the rainfall, but also there was a lot of contribution by the urbanization. So that's another effect that you're doing on top of climate change. So when we're looking this climate change contribute for specific hurricanes, these studies need to be performed case by case. So if the reporter calls me while Helene is happening and wants me to give an estimate, I can't do it because I can't do research on the phone on the fly. So this has to be done each case study by study. And basically what we have been done so far, being able to estimate the amount, the probability of how much the rainfall of a hurricane was increased due to climate change, or the intensity was increased, or the flooding due to storm surge. So these are the things that we have been able to say so far. And in some cases, we have a big effect, like Harvey, 6 to 20% increase in precipitation is a lot of precipitation increase. But in other cases, you cannot say so clearly, and the impact is climate change is smaller. So it's not like every single hurricane we're going to be the same thing. We have to see case by case. How about the future projections? Now, what's going to happen? So far we talked about what has happened so far. How about the future? So actually the results are kind of similar to where we're talking about what we can say about what has happened. And basically, we have been saying similar things for many years already. So similar to what we have noted so far, the rainfall precipitation associated with tropical cyclones is expected to continue to increase. And we are going to expecting about 7 to 20% by the end of the century if we have a global warming about 2 degrees, which we already close to reaching in a few years. And if we have more, then these numbers will be different. We also have the intensities of the hurricanes, the mean intensity increasing about 5 to 10% globally on average. This is average, so then we have individual hurricanes. Will be different. We also, as we already noticing, more of these Cat 4 and 5 hurricanes we're already noticing, we expect there to continue to increase in the future. So this is, and then we also expect the combination of more intense hurricanes and sea level rise to lead to more storm surge. Big questions that we have. The total number. I mentioned that in the last 30 years they're decreasing. But we actually have a big uncertainty in the global number, what's going to happen in the future. And if you ask me 10 years ago, I would say that all the studies are pointing toward a decrease in the total number. That's not the case anymore. There are some studies actually that are projecting to an increase. And what's interesting, different from rainfall that we understand why they're increasing, or intensity, which we have a very good theory for hurricanes, we do not have actually a very good theory for number of hurricanes. So they're based on models, and when the models have divergence, that's when we start having big uncertainty. So there's a lot of people in my field that they're studying that right now. And one of the questions is, remember those disturbances that come and become hurricanes? So some people are arguing if what's going to happen in terms of the numbers in the future is going to depend on what happens to those disturbances. We have fewer disturbances, we have fewer hurricanes, we have more disturbance, we have more hurricanes. But it's harder to understand and simulate those in our models. So that's right now what a lot of people are studying. And if you look here, here are our uncertainty in frequency, categories, intensity, rain rate globally. Now if you start looking at different regions, I don't know if you can see that, but basically a message is the smaller the region, the more uncertainty we're going to have. So then if you start, okay, what's happening in the Atlantic versus the Western Pacific versus the Australian region, then the uncertainty is going to be larger. We're going to know less about what's going to happen. So if you come and ask, should I buy a house in Miami, and what's happening in a house in Miami, I'm like, I cannot say. So to summarize, important to remember the hurricanes are part of the climate system. So they are not appearing because you have climate change. They are already part of the climate system. The anthropogenic climate change currently and in the future is already changing the hurricane characteristics. The attribution of trends is difficult because of the data quality, and also there's a lot of variability year to year, so it's very hard to do. It's not doesn't mean it's not happening, it's just hard to do with the data that we have. We expect the hurricane intensity, precipitation, and storm surge are likely to increase in the future, and there's a lot of uncertainty in the number of hurricanes and the regional trends. Thank you very much.
So Suzana would be happy to take questions. Okay, we have people who will give you microphones so that everybody can hear.
Thank you. There you go. Thank you very much. And so if I was living in Tampa, Florida, which I'm not, and I'm a reporter for the Tampa Tribune or whatever, and I've seen some of the real estate metrics that they have nowadays in any house you buy. It's in a flood zone. It's close to the sea level. This and that. You can't do regional, specific, but we can sort of try to get down and dirty. Would you recommend for me to leave Tampa, or do I go to, Northern California where it could be a fire, or it could be a dry season, a drought, and if Vermont has a 5-year drought, then that's going to be like Washington State or British Columbia with fires. So let's just talk hurricanes. Should I stay in Tampa?
So Tampa, every time that people discuss Tampa, is always one of the worst scenarios that put the modeling that we have is if there is a big storm surge in Tampa. That's why there was so much concern when Hurricane Milton was making landfall and if it was going to affect Tampa or not. And storm surge is very hard to make forecasts. You have 20 miles difference on where the storm makes landfall. You have a completely different storm surge because it depends on how the winds are. So people are like, okay, Tampa has been lucky and had been affected by hurricanes for a long time, but I would not move to Tampa. But the truth is, Asheville was one of the places that everybody's saying is a good, safe place for climate change, and you just all know what happened. And if you go into history, there was storms, not as intense rainfall, but it was not that it never happened before. Rainfall due to hurricanes in that region. But we have more people, we have a bigger city. It's also, yeah.
Thank you for the presentation, very interesting. I was wondering at the end you showed future projections. And I also understand that globally there are all around the world different feedback loops, like melting of the Antarctic ice, or methane release in wetlands. And I'm wondering if the future projections take into account the many feedback loops around the globe.
Yeah, so one of the typical ways we do global projections is using what we say global climate models. And they are actually, in the 70s, they were much less sophisticated. But right now, they are very sophisticated. And they do have ice, they do have different gases, they do have we're modeling all that together. So I can promise that every single aspect that you mentioned is perfectly modeled that because, but we are trying these very complex climate models do try to take all these factors into consideration.
And with that modeling, do you also incorporate the AMOC, the Atlantic Meridional Overturning Circulation?
Yeah, so
Because-
that's part of the ocean circulation. It's there. Yeah, so
and that's included in the models?
Yes, yeah. The models, they simulate that themselves. So that's we make tests to see if our models are simulating the real Earth. And so they were they have to pass some criteria. And, there's some of them, it's having an AMO, yes.
Two quick questions, Suzanne. First one is there anything that would lead to this prediction that higher temperatures would be associated with a decreased number of hurricanes? Is that anything?
So what has happened is that when you have a warmer atmosphere, end up being what we call more stable. So you need an unstable atmosphere to form storms. So then this warmer atmosphere is kind of more stable. So it seems that one of the ideas is like it's kind of harder to start the hurricane. So because the atmosphere is kind of more stable. But then once it's there, you have all the ingredients to make it very strong.
Thank you. The second question is, without going into too much detail, but it's intriguing that there would be an estimate of 6 to 20% increase in precipitation for one specific hurricane. So obviously they did a post-mortem on that hurricane. What are the steps they would take to come to a conclusion that on average, that 10% of the increased rainfall was due to temperature increases? Did they look at the temperatures that were where the hurricane developed and modeled that, or how is
So
that
one,
done?
I know that you're very good at numbers. So one of they, for instance, get rainfall data for instance, from that region, from Houston, and you look at their, distribution and the tail of the distribution for instance, in the period 1940 to 1970, and then you do the same thing in the latest period, and you see the change in the whole statistical distribution and the tails, and now you localize where that rainfall that we had for Harvey is, and then you see the probability of having that amount in rainfall in like 40 years and the most recent 40 years, and you see that probability change. So that's one way of doing it, just with data. We don't need models for that. Or the other way is you do some kind of modeling, and you simulate that hurricane many times with and without CO2. And then you compare the properties of those many simulations with and without CO2.
Can I just ask one final question? When you say CO2, that's substitutable for temperature change?
So
Because let's say, for example, would you see exactly the same result if it was not CO2, just some other form of temperature change? The identical temperature changes from another source.
So the way we actually put CO2 in the atmosphere and let the atmosphere respond, and it warms up by responding to the amount of greenhouse gases there is in the atmosphere.
So yeah, we just had an election this past week.
I'm aware.
Hey, I didn't think that would be new information. How does this affect your oncoming work? To have a president who believes global warming is a hoax. Now, we've had practice in this. We had them before, so it's not a new drill, but please, tell us this won't shut down your work.
Well,
and how are you going to cope with this?
Well, we coped before, and we hope to continue to. One of the unimportant worries that a lot of the climate data come from NOAA, the National Oceanographic and Atmospheric Administration, and part of the Project 2025 is to disband NOAA. So that is a very big concern. Another important issue is we do a lot of our research based on receiving federal funding for research. So how that's going to affect, I'll let Steve deal with that. And yes, it's a big worry, and I hope, that there's pressure enough from the rest of the world that we're not going to go in a completely off direction. I don't know if you saw, but Exxon, of all places, told Trump not to get out of the Paris Agreement. So I'm going to continue my research, and it's so important for us to know what's going to go.
I just have a quick question about the slide regarding Hurricane Harvey, and I believe you mentioned that it hovered over Houston for a longer period of time. Does climate change impact hurricanes in terms of their speed of moving across land?
Yeah, so there has been a few studies looking into that, and there's some indication that it might be doing, in some cases, having more of these storms that just stay in one place, because they stay in one place because you basically have a pattern in the atmosphere that you have like two highs, one in the other side, and the hurricane basically stuck in the middle. So these kind of situations, and for instance, some of the flooding in Europe are also caused for this kind of pattern. And so that might be happening in the future, but it's not as robust yet a result as, you know, the increasing intensity and rainfall. So there are a lot of things that we have some hints already, but the results are not as concrete and robust than some other ones. So that's a lot of where this research is doing.
Thank you.
Thank you so much for the presentation. I have two questions. So first, can you illustrate a little bit more on how oscillation events impact hurricane, and how do you handle that while you are doing the attribution analysis?
Oscillations. For instance, we have El Nino Southern Oscillation. Well, when we have El Nino Southern Oscillation, it's basically warming in the Pacific or tropical Pacific. And when there's this warm, enormous warming in the tropical Pacific, it basically affects weather everywhere. And one of the consequences in terms of the Atlantic is that, remember the vertical wind shear that I mentioned? So it changed the wind pattern such that there's more wind shear in the Atlantic. So a year that you have El Nino, you end up have fewer Atlantic hurricanes. And that's one of the reasons this year the forecast was so high, was that because there was the opposite, a La Nina in the Atlantic, which contributed. So you have these fluctuations, for instance, in the Atlantic. So you have to take into account not this variability. It's not only a trend, like it's just not go up like that. So that's why make our work harder, because it's like you have to take into account not what climate change is doing, but how, for instance, how El Nino is going to influence hurricanes in the future, and is El Nino going to change or not? So that's why we need very complex models and all these things together. So you got a very important point, that, you know, we have on top of these trends that we're having in temperature, we also have these fluctuations, these many climate modes that we call.
I also have a second question quickly. So just thinking from the application perspective, I guess, so when people do, for example, seasonal to sub-seasonal forecast, do you think they incorporate like the trends that you have mentioned in their projections?
Yeah, so when we do seasonal forecasts, for instance, NOAA, when they do their way to classify El Nino and La Nina, they are doing like a change in their climatology every 10 years. So what they're called is then mean, and what their anomaly changes, and that's automatically taking into account that the temperature of the climate is changing. So people do that in different ways, but we usually take that into account. When you do like your 5-day forecast, you don't need that, but even for, you know, El Nino and La Nina seasonal forecasts, we do take that into account.
I guess we'll take one more question.
Ooh. Well, I hope this is worth it. You know how we have like ways to build buildings to make them perform better in earthquakes? Is there a way to build to make infrastructure or buildings survive hurricanes more? And is there any data about any policy that has worked to help protect communities from man-made risks?
Well, there's a lot of work on that. I have not personally working on that, but there's a lot of work. For instance, very interesting case was in Australia, and they had a cyclone in the 60s that devastated northeast part of Australia. Immediately, they changed the building code in Australia to resist better hurricanes. But after then many years of doing better, they hadn't had a lot of hurricanes in that specific region. So now people saying why we're spending so much, because if you strengthen your building codes, the houses become more expensive. So then people say, oh, why do we have this very strict building code? And then people start relaxing again. So it is, and in the case of Hurricane Milton, all these tornadoes, a lot of the people that died were the ones that were living in mobile homes. So this is a direct relationship with how we are building our houses and where they're building them and the impacts that we're having. Yeah, so.
Okay.
Yeah, there is things to do, but.
Okay, well, thank you, Suzana. So I was saying that we moved here in 1996, and speaking of trying to just decide where to live, we live very close to here. We live in the area, and my wife and I, who's also a research scientist here at Lamont, and we're both geologists, we were shown around by the real estate agent, and she showed us a house. There was this nice little trickling brook behind the house. And we were looking at it saying, oh, this is a really nice place. And it's nice little brook by the backyard. And we said, no, we're not going to buy this house because we're too close to this trickling brook. And it was not too long after that, those of you who live around here, that you might remember Hurricane Floyd came through, and if we had bought that house, we would have been really sorry. So think about things like that. I want to thank everybody for joining us this evening. Your presence here really is meaningful to us as we're celebrating our 75th anniversary. And that is really a milestone for us. It reflects 7.5 decades of groundbreaking research and discovery, and it's really made possible by supporters like you all. So I just want to note that your partnership can really help us to generate our next big scientific discoveries. So please consider supporting this consequential work here by making a gift to the Lamont-Doherty Earth Observatory. It's easy to find where to donate. And we are grateful for your interest in this profoundly important work, and we look forward to continuing the conversation. There will be another Lamont lecture very soon. So thank you very much for coming, and we hope to see you soon.